Okay, well, I guess I'll just go over this until people start showing up. So for week 11, the activity for day 3 if I can find it. We're supposed to analyze graphs. So first graph we're supposed to analyze was y equals 5x minus 7 over x squared. So for the domain, x cannot equal 0. The x-intercept, you set the top equal to 0 to find x equals 7/5. There's no y-intercepts, because when you put the zeros in for the x's, you get 0 over 0. Vertical asymptotes, you set the bottom equal to 0 and get x equals 0. For vertical behavior, as they approach that asymptote on both sides, they're going to be approaching negative infinity. Horizontal asymptotes, the upper degree is smaller than the lower degree, so it's y equals 0. And if you test it, yes, it will cross at 7/5. It'll cross that asymptote. First derivative, you get negative 5x plus 14 all over x. So critical points include 14/5 and x cannot equal 0. First derivative chart, the sign changes from negative to positive around 0 and positive to negative around 14/5. 14/5 is therefore a maximum. Second derivative is 10x minus 42 all over x to the 4th. So possible inflection points would be 4.2 and x does not equal 4. X does not equal 0, excuse me. So then the sign changes from negative to positive for the second derivative around 4.2, which makes that an inflection point. So when you graph all those attributes together, you get something that looks like this. Okay, next one. Analyze the graph of y equals x over the square root of x squared plus 2. Domain is from negative infinity to infinity. X-intercepts, you get 0. Y-intercepts are also 0. Vertical asymptotes aren't any. Because the bottom does not, when you set it equal to 0, you get an imaginary number. Vertical behavior, that's not applicable. Horizontal asymptotes, we get plus or minus 1 because it's x over the square root of x squared, and when we have a square root of x squared, that tells us that it's going to be the absolute value of x, so that gives us a plus or minus. And it does not cross those asymptotes. First derivative, we get 2 over x squared plus 2 raised to the 3/2. So there are no critical points, so we can't make a first derivative chart. Second derivative, we get negative 6x over x squared plus 2 raised to the 5/2. Possible inflection points would be x equals 0, and it is an inflection point because the concavity goes from positive to negative there. So we get a graph that looks like this. Okay. The domain for y equals 2x to the 5/3 minus 5x to the 4/3 is negative infinity to infinity. X-intercepts, when you set those equal to 0, you get x equals 0 or 125/8. The y-intercepts are 0. There are no vertical asymptotes. Therefore, we don't need to look at the vertical behavior. Horizontal asymptotes, there are none, so we don't need to worry about it crossing any asymptotes. First derivative would be 10/3 x to the 2/3 minus 20/3 x to the 1/3 equals 0. Critical points include x equals 0 and 8. And 0 would be a maximum, 8 will be a minimum. Second derivative is 20x to the 1/3 minus 20 all over 9x to the 2/3. Inflection points could include x equals 1 or x cannot equal 0. We find that their inflection point is at 1 because the concavity changes. So when we graph, we get something that looks like this. Okay, lastly, we want to analyze the graph. So the domain is going to be x does not equal 0 for y equals e to the 2 over x because x can't equal 0 because that would give us something undefined. There's no x-intercepts. There's no y-intercepts. Vertical asymptote is at x equals 0. And that's, again, x can't equal 0. Vertical behavior, did I not finish this one? I wonder if I didn't finish this one. Oh, no, I did. We're going to go toward positive infinity from the right side, and from the left side, we're going to approach 0. So horizontal asymptotes we get by taking the limit of e to the 2 over x approaching infinity and negative infinity, and we'll get 1 on both of those. Does not cross. First derivative is negative 2 e to the 2 over x, all divided by x squared. Critical points would be x does not equal 0, but there are no sign changes in the first derivative, so that is not an extrema. Second derivative is 4e to the 2 over x times 1 plus x. For that one, we get x cannot equal 0 and x equals negative 1. There's an inflection point at negative 1. So we get something that looks like this. Okay. And that is it for week 11 group meeting. Yes, we'll try and see if anyone shows up to group 12. Thanks.